What we are going to do is to try to simplify some of the modern physics by using a game called Minecraft. Many mechanics in the game reflects how some things work in the real world, which is why we have opted to use it. We are going to start by talking about atoms, how the theories of today and history came to be. Atoms is today common knowledge. Everything around you is built up by very tiny particles called electrons, protons and neutrons, which forms atoms, which in turn forms molecules, which in turn forms matter. But imagine living in Greece around 2,500 years ago, when no one has ever heard about atoms or molecules before. And all that is known is that they live in a world of mountains and plains with flowers and trees. On land and in water there are plenty of big and small creatures. You hear about a thinker named Democritus, who claims that all the vast richness of what exists actually hides an underlying simplicity, that everything is built by atoms and emptiness. The atoms so tiny that one can't see them, but they are fundamental and can't be split up to smaller pieces. They all just float around in emptiness, colliding with each other or merge with each other, and is the source to all objects. You could not fathom that everything that is so different could all be built by simple atoms. This thought became the driving thought for driving science forward. When Empedocles put forward the teachings about the four elements, earth, water, air and fire, it was a new version about the same idea. The completing hides the simple. Aristotle accepted the teachings about the four elements and forgot about the atoms. This led to the atom theory being dead for almost 2,000 years. It wasn't until the years of 1600 AC before the theory of atoms took a new uprising, when Robert Boyle did experiments that indicated that there are some elements that couldn't be separated into simpler elements. These became known as chemical elements. It was Joseph John Thomson that finally discovered the electron in the 1890s, when he was conducting an experiment with cathode rays, electrical currents through a tube filled with diluted gas. The results were astonishing. Thomson found that there existed negative particles even smaller than atoms, which had a mass of only 1/1,000 of a hydrogen atom. Thomson called these particles electrons, and with these negative particles there must also be positive ones. So he designed the first atom model, the Bunn model. In the 1890s, there were several large discoveries that shortly followed one another. X-rays, 1895, radioactivity, 1896, and the electron, 1897. The year 1896, Ernst Rutherford from New Zealand arrived at Thomson's lab in Cambridge. His first discoveries was that there existed at least two types of radiation, alpha and beta particles, and he also showed that what they consisted of. This radiation had a connection with atoms, but what was the question? Rutherford conducted experiments that disproved the Bunn model by shooting alpha particles through a gold foil and discovered that a small amount of particles bounced back the way they came from. This proved that the Bond model was wrong, and therefore, after several years of analysis, he came up with a new atom model, Rutherford's atom model, or the planetary model. This model looks a lot more like what we have today than the other theories, but it was still not entirely complete. It was a man named Niels Bohr that managed to continue with the work on atom models. Rutherford was stuck with the stability of his planet model. Bohr focused on the simplest case, a hydrogen atom with one core and one electron. The core with a positive charge and the electron with a negative one. Bohr imagined that the electrons circled around the core like satellites in different orbits. Just like satellites can be lifted out of their orbits, he imagined that the electrons could do the same by obtaining higher energy levels. By sending energy with a specific energy level, you can raise the electron's energy and therefore its orbit around the core. Each atom has its own specific energy level for each level of energy, so it varies with every atom how much energy an electron needs on a specific level to be able to increase its orbit. But even Bohr's atom model is not enough. Bohr even stated himself that it was unfortunate that his atom model worked so well with only the hydrogen atom. Bohr's atom model actually led into a dead end that took more than 10 years to get out of. Bohr's atom model was excellent for atoms with one electron, but was not enough for any atom with more than one electron. Bohr's postulate concerning the energy levels were however correct, but the rest had to be replaced with quantum physics. But that's a whole other piece of cake, which we will not go into. Water has a general density, but can be denser or less dense than its general density. And it is this general density that we will show you a bit how it can work. We can show you a bit how density can work by having a bunch of materials in the game Minecraft. If we take air, which has very low density, we can move through it without feeling it. But there exists resistance, just that we can feel it if we move slow enough. But if you came up in higher speeds, it could slow you down considerably. If you use water, it is considered to be a lot more dense than air, but not enough to completely stop us, but enough to slow us down heavily. But if we start using more solid material, such as large amount of dirt, we start to get somewhere. We cannot simply move through dirt. It is much more dense than air or water. What we can do is try to remove it by using our hands, so that we can pass. As you can see, the game shows this density by how hard it is to remove a block of material in question. Even denser material is wood. Now in the real world, it is not possible to harvest wood by simply trying to remove it with your hand, but it shows that wood is considerably denser than dirt. Even harder is stone. We cannot even remove it with our hands in the game. We need something to be able to break down the stone. The solution is using something like a pick. With a pick made of wood, one can harvest the stone. Iron is a material that is harder than stone, and once again we need something stronger than our hands or our wooden pick to be able to break this down. With a pick made of stone, however, we can pick iron apart. Gold is something many know to be very dense, but it's also a soft metal. So the game shows this by having golden tools to be equal or even worse than iron tools. But fact is that gold is denser than iron. It's just more flexible and therefore a bad choice for this work. Now that you've seen and heard a bit about both atoms and how density works, you may have a deeper understanding how atoms work and from materials. Thank you for watching. The